Section 1, Video 2. Let's take a look at the process of dealing with a rational equation where we do not have one fraction equal to one fraction. Now, there's great detail as to how to do these questions, and then the following steps down here take you through each one with this example. Now, the first thing is to factor the denominators if necessary, mainly if it's a binomial or something like that. So in this case, it's done. Determine the least common denominator. Well, if you look at this problem, we're going to use the common denominator, but a little bit differently than we had when we're just adding and subtracting fractions. The least common denominator, or the common denominator, is the least common multiple of the three denominators. So if you look at the three denominators, you have a 6 and a 3. So the common denominator, the least common multiple for 3 and 6 is 6. The k, again, what do they have to have? They all have to have at least k squared. So we're not talking about greatest common factor, we're talking about least common multiple. So we can get all of those to become a 6k squared. So this was taken care of. The least common denominator is 6k squared. Now, restrictions are solutions that you can get, but if you put it back in, it wouldn't work because of the way the problem is set up. So in other words, we look for things like what would cause a denominator to become a 0, because we cannot divide by 0. That's the main thing you think about with fractions. So what value, if this is the least common denominator, can k not be? So in this particular case, k cannot be 0 because 6 times 0 squared is 0, makes the fraction undefined. So one little thought there that goes into these kinds of questions. All right, next we want to get a common denominator for all terms. So back to this question. If I need 6k squared, the first one, 6k, needs another k. So I multiply top and bottom by k. Now, one thing that I want you to think about is if you ever have fractions being subtracted, I recommend making it an addition problem and putting the negative with the numerator. And if it's a binomial, you'll have to distribute, keep that in mind, but it's going to clean things up and less errors occur because of that adjustment. So keep that in mind. So back to the question, the second fraction has a k squared, it needs a 6, so multiply top and bottom by 6. And the last fraction has a 3k, it needs to be multiplied by 2 to make it a 6, and another k. Now if that is done, then our new fraction will be k over 6k squared plus negative 6, because that's 6 times negative 1, over 6k squared equals 10k over 6k squared. Now here's the good news. At this point, when we have a common denominator, we can just get rid of them and take them away, because now it's just a matter of focusing on the numerators. And this is now our problem. So instead of going to the next page, I'm going to solve this, and I'm going to subtract k from both sides. Those are like terms. We get negative 6 equals 9k. Divide both sides by 9. And k equals a negative 2/3 if you reduce. Now we said k cannot be 0, and it did not come out to be 0, so that would be considered our solution. So if we do, we've taken care of this part, and this part. So this ends Section 1, Video 2.